point is that? It's this point right here. Do you have anything you can do to that algebraically? No. You want to be able to cancel what? Bless you. What do you want to be able to cancel? Yeah. You want to be able to cancel h, but can you cancel h out of that? Are you okay with how they got to here? How do you feel about that? Are you okay with getting to here? Okay, so let's take a look at here. You're going from, you're supposed to do estimate the instantaneous rate of change. So you're doing the limit as h goes to 0, right? So are you okay with that, the first one?
Yeah.
So you plug in the numbers and you get these two things right here. So this is when you plug in 0 plus h right there, and you plug in 0 plus h right there, and you end up with, you've got to make sure you be real careful about the negative signs. You see those brackets that are there? Are these brackets really important?
Yes.
Yes, especially the second ones, because what does that negative sign do? That negative sign goes into both of them, right?
Yeah.
So you end up with minus 3. That's how you get the plus 3, because you're subtracting negative 3. Does that make sense?
Yeah.
So you get to here, but can you do anything with that algebraically? Algebraic wall, at least for now, right? So how did they get this? Where did this come from? What do you have to use? Yeah, you have to use your calculator. So specifically, what did you make? A table. You need to use your calculator and use a table right there. So you get you end up with numbers really close to negative 3.294 and negative 3.298. So how did they get this number right here? It's just the average of the two. It's just the average of those two.
Is it using a calculator or a table? Or
Yes, that's the same thing. So if you get to this point, I want you to make a table identical to this. You're going to do this a whole bunch. When you're using the limit definition of derivative, this difference quotient, the numbers you're going to need to use are right here. You're going a little bit to the left, and then you're going a little bit to the right. A little bit to the left and a little bit to the right. The slope of the tangent line between the points. So there's the first point right there, and there's the second point right there. So that point is 1, -1, and that point is -1, 2.5. So what are you doing? You're just literally calculating the slope. Exactly. And then here's the third point right there. These are also just estimates right here. I mean, does this give you the function? It doesn't tell you the function anywhere in there, so you have to estimate those points. But it looks like they're about that. Does that make sense? See, all you're doing when we're finding average rate of change is slope between 2 points. The points might be obfuscated a little bit, but not that much. You asked about 2, somebody?
Yes.
So again, it says the average rate of change of y equals x cubed. It's giving you the function on 0 to 2 and 1 to 2. Those are intervals, not points. Those are intervals, not points.
Yeah, that's what confused me.
So this one, what 2 points do you have for 0, 2? What are those points right there? That's 0. Plug in 0 into x cubed. What do you get? And what's the other point? 2 comma 8, because it's 2 cubed. And then what are the points for this one? 1 cubed is, and 2 cubed is? Sorry, 1 cubed is 1, and 2 cubed is 8. So you have 2 pairs of points. That's it. It's 2 pairs of points. 2 pairs of points. So here's the thing. If you're looking at x cubed, what does x cubed look like, everybody? What's the shape? What's the shape?
1 cubed.
What does it look like? X cubed. X cubed. Use your hands. What does it look like? Everybody use your hand. Goes up, kind of like this, right?
Yeah.
So if you're doing the average rate, something like that, yeah. If you're doing the average rate of change from 0 to 2, here's from 0 to 2, right? But then if they ask you from 1 to 2, let's zoom in a little bit here. Is it going to be steeper or shallower? Which one's steeper, the black line or the green line? You can't really see it there. The black line, right? So theoretically, did we get something that's steeper? Yeah, it started at 4, the 4, and then it turned into 7. It's getting steeper. It's getting steeper. How do we feel about this so far? You need to be able to make that table. You need to be able to use your calculator. How many people started like that? Did you get -3 when you plugged in -1? So what's the big challenge? Not the big challenge, but what's the algebraic challenge at this point? What's the algebraic? What do you have to do algebraically next? Yeah, you have to take this and you have to plug it into the original function, right? So it's f of -1 plus h. What is that? That's -2 times -1 plus h squared plus -1 plus h, right? And where does that end up going? That ends up going up above, right? So you end up with something that's a little long to write. It's not that bad. You end up with -2 times -1 plus h squared plus h like this.
You don't simplify that out.
You will eventually, but please just do it step by step. You could. You're going to be forced to simplify this, right? Why are you forced to simplify it at this point? Well, you want to be able to cancel the h, so you're looking to make sure that you can. If you can do this algebraically, you have to be able to cancel the h. Is it really easy to mess up the algebra? Yeah, so if I clean it up over here, it's negative 2 times what? 1 minus 2h plus h squared minus 1 plus h. So is that negative 2 plus 4h minus 2h squared minus 1 plus h? So what does that simplify to? How many h squared? Negative 2h squared, I think? So that takes care of this, right? And then what do I end up with? How many h's do I have? 5h. So that's this right there, minus what? And is that, you really want that, right? That's really helpful because now you have the limit as h goes to 0 of negative 2h squared plus 5h minus 3 plus 3 all over what? H. What cancels now? The 3's are gone, so you're left with the limit as h goes to 0 of negative 2h squared plus 5h over what? H. We good so far?
Yeah.
What can I factor out? So I end up with the limit as h goes to 0 of negative 2h plus what? 5. And what happens as h goes to 0? What is that? 5. 5, 5, 5. So the instantaneous rate of change there is 5. Is it really easy to mess up with the algebra?
Yeah.
It's super easy to mess up the algebra. Super easy. Here's a question for you that you don't have to do any actual math for. You can just look at this and do this in your head. What kind of function is f of x in this case at the bottom of the screen? It's a linear function. So what's the average, what's the instantaneous rate of change at 0? You can tell me what it is. No. What's the rate of change everywhere on that line? Nope. Where's the rate of change in a line function?
4.
Yeah, the slope. What is the slope? The definition of the slope is the rate of change, right? So what's f prime of 0 for this one? Is what? 4. What's f prime of 1? 4. What's f prime of 2? That's the whole definition of a line, that the average rate of change is what? The same everywhere. It's the same number because it's the coefficient. Oh, look at that. It's the same thing. Okay. Oh, boy. Oh, that's a good one right there. Get to the board, everybody. Get to the board, everybody, with a partner, someone you're not sitting next to right now, and try that one. You're going to need a calculator. Okay, so when you did the table, so when you did this out, you should have ended with, you're doing the limit as h goes to 0 of log of 10 plus h minus 1 over h, because 1 is log 10. What's the invisible base? 10. So then when you make the table, you end up getting infinitely close to something. It's going to be about, what, 0.434, something like that?
Yeah.
Something like that, right? Something like that. The table value cuts it off at 3 decimals. So if you want more than 3 decimals, you're going to have to do y1 evaluated at each one of these, like y1 evaluated at 0.001, etc., to get more decimal places to do it that way. Yes, Alex?
Where did we get this limit of h going to 0, a plus h?
Yesterday. So yesterday we did this on average rate of change right here. So right here it was, where was it? It was in the notes. Let me find it here. You ran into an algebraic wall. You ran into an algebraic wall. You ran into, where is it? I had it here. You ran into this wall right there. You ran into that wall. So you had to use a table. And more decimals are probably needed. So just watch out for that. This is a wall right now. For you right now. Right now. Okay, get back to the board, everybody. Get back to the board and do another estimate on this one. This is a good one.
Let's go faster. Go. Communication skills are already up.
I can only get better.
We know that. So negative 2 equals negative 1 half. So
1 over negative 2 plus h. Sorry. No, 1 over x. We got that equation. 1 over x.
No.
Oh, and then we started there. So limit as each goes to 0. Wait, hold on. I think it's H approaches 0. 1 over 1 over x plus, or 1 over negative 2 plus h.
1 over negative 2 plus h. That's
And then minus, and then minus 1 over negative 2.
Okay, so yeah. So we just got
Minus,
this negative.
so plus 1/2. Just do plus 1/2.
And that's all over h.
Yeah. So what we could do is
Yeah, positive 1, 4. Oh, this would be negative minus 1/2 minus 1/2. No, minus 1/2 and minus 1/2.
Wait, is this true? Negative 1/2 plus 1 over h is the same as 1 over negative 2 plus h. Mr. Seamon?
Yes.
Is that true? I'm just having a calculator for us today.
So you're doing it at negative 2.
Would negative 1/2 plus 1 over h be the same thing as?
Put the whole thing over that whole thing. Whole line. That line. 1. Okay.
Does that equal?
You're not actually changing how much it is.
No, not at all. No.
I don't know why.
No, don't do that.
The
Please
other
don't
way
do that.
around.
Don't do, yeah, if it was on the numerator, yes. No. And it was done in BC calculus. Like this kid's cruising along, he did the exact same thing, and I'm like, no. I mean, think about it. You can like look like ready. Like 1 plus 2 plus 3 does not equal like 1/2 plus 1/3, right?
Yeah.
Like no, just pick numbers. It doesn't work.
Yeah.
Okay. So do you run into a wall, or can you simplify that?
I think it's a wall.
Well, try simplifying it. See if you can simplify it. Wait, why are you squaring that?
Actually,
Times 1 over
Okay. Okay. Yeah, so we run into the wall up here.
No, but where's that square coming from?
Yeah, I thought that the equation was square.
You could try. You could just see.
How else would you do it?
You don't. You enter. You go. You put the calculator.
You could see if it's algebraic. See if you can do it algebraically.
We're gonna be able to have our calculators on the test.
You'll be able to do it for at least some of it because you have to make a table for some of it. Yep.
Mr. Seamon, this is a wall here.
Is it though? Have you tried any algebra whatsoever?
No, but I'm gonna go out on a
And erase all of that because you didn't
Yeah,
square
I
anything.
understand.
You haven't actually tried anything, so no, I can't tell you if you've hit a wall or not.
Well, could we take away the parentheses and then just negative 1/2 cancels with 1/2?
That's not the function. What is the function? What is the function?
Yeah. So it'd be 1 over.
Negative. Yep. Nice. So if you want to add that, you need a common denominator. Where'd you get the negative?
Yeah, where'd you get the negative 2?
Because you're plugging in negative 2. You're plugging in negative
it's
2.
Not, so A is just that value. It's not. Well, I thought it was what f of x equals.
No.
Okay.
Remember, the first thing I'd like you to do every time you do this is write this down. F of a plus h minus f of a all over
So
h.
negative 2 plus h equals
Mm-hmm.
plus 1 over 2. So you could just make a common.
Each step is what's in the yellow. So now at this point, you see this, everybody? At this point, you don't assume you hit a wall until you actually hit a wall. So in this case, adding fractions, what do you need? Common denominator. What's the least common denominator going to be? 2 times negative 2 plus h over what? 2 times negative 2 plus h. That's just a complicated form of what number? So are you allowed to multiply by that? Yeah. So you have to distribute this in. You take this. When you take that and you multiply it by that, what term cancels? When that blue circle multiplies times this fraction, what cancels? Yeah, so you end up with what? You just end up with 2 plus, and then when you multiply times 1/2, the 2 cancels what? What are you left with? Negative 2 plus h all over, and on the bottom, h times 2 times negative 2 plus h. What cancels on top now? Is that really, really nice?
Yeah.
Because now what are you left with? H over 2h times negative 2 plus h. Something cancel? The h's cancel. Is that the entire thing you were looking for?
Yeah.
Yeah, so now what do you have? You have the limit as h goes to 0 of what's on top? Don't say 0. 1 over 2 times negative 2 plus h. What's that equal when h is 0? What is that? 1 over negative 4. So the instantaneous rate of change without your calculator, you just prove that it was negative 1 over 4. What does this look like? What does this is it in? Looks like this, right? So at x equals what? At x equals -2? Where's -2 going to be about? Let's say right about like here. So you're looking at that point. What's the tangent line at that point going to look like? Is it going to have a positive or negative slope?
Negative.
We just found that it has actually a slope of what?
-1/4.
-1/4. Could you find the equation of that line?
Yeah.
To write the equation of a line, you need two things. You need a point and a slope. Do we have slope?
Yeah.
What point is that right there? The x value is -2. What's the y value?
We'll say negative.
Well, what's the function? Y equals 1 over x. So what's the y value?
1/-.
Yeah, so -1/2, like this, right? Do we have a point and a slope now?
Yeah.
We have a slope and we have a point. We have a slope and we have a point. So what form of a line should we use? Yeah, y minus y1 is equal to m times x minus x1. I don't need slope intercept. I don't need slope intercept. Unless I say I need it, you can leave it like that. You're not done. You need to plug in values. Can someone tell me what the equation is? Arvin, what is it? Y minus?
Y plus 1/2.
Yeah, so y minus -1/2 equals, yep.
-1/4
Mm-hmm.
times x minus -2.
Yeah, and the one thing I'd like you to do to clean that up is do what you were doing, which is get rid of the double negatives. So it's x what?
X
Plus 2. So if we were to graph both of these things, so do that on your calculator right now. Graph 1 over x and also graph that on your calculator as well. And see, right?
Yeah.
What was that second one? It was going to be... Looks like it's going to be -0.5. Is it plus a quarter? No, it's minus what? 0.25 times what? X plus 2? You got to graph them, everybody. So if I graph this, look what's going on, everybody. Does that match what we have?
Yeah.
Can you graph it? What do you think, everybody? Can you graph this?
Yeah.
Yeah, something like that to get bigger. Let's see if I can make this bigger. There we go, a little bigger there. So it's hard to see because the resolution's pretty bad. So what could I change to see this better?
Window.
Window. So right now, if I click on window, it's from -10 to 10. What should I change it to, maybe? Yeah, -5 to 5. Oh, I did. So -5, delete, to what? 5. And then I should change the y too, right? -5 to 5. When I graph this, which one is that? That's 1 over x. And then does it look like that's a nice tangent line?
Yeah.
Yeah, it's pretty good. It is pretty.